I sent out a few announcements, and please take a look because some of this involve some segment of code that might be really useful to all of you to develop some program. There are maybe 10 or 12 students show up in the office hour today. I really appreciate that you coming here to bring the question that you have. During the office hour, either me or the TA will have a better idea about what's the gap between what we think you understand, what we think that you are, versus what is the missing pieces that actually we can provide you. I mean, just be honest with you, I think I make a comment today, maybe to one of the TA. I said, well, I have been doing programming for so long, and such that I actually forgot the feeling about the first time when I learned how to do programming. So you have to kind of understand or forgive me. Sometimes I just went ahead to actually talk about a lot of things, which is assuming some of the stuff you already know, but it's not. I mean, I just really want to get that kind of feeling from all of you during the office hour or during the one-to-one interaction. The way I run office hour is that I typically use the room 2359 to gather all that is my research lab, by the way. So we can actually have about 20 students sitting there. And the way I want to run is I actually want to collect what is your particular issue about the homework, about the course, or about the exam. And then once I gather all your input, I will be able to organize to address to a group instead of address to individual student. I mean, we have to be realistic. This is a really huge class, 170, 180 students. And it's really challenging for the instructor, the TA, try to handle the help that you need in scale. Okay, so I think it will be better if we can kind of consolidate a little bit. So therefore, I really appreciate if before the class, oh, sorry, not before the class, before the office hour, if you can send me a message or email to just inform me what kind of question you have, that will help me to consolidate, and maybe I can even do some preparation for your question. Okay, so I think office hour is an important part of the class. That's actually give me more time for me to breathe, and then for me to actually understand the things I didn't cover well in lecture, for example. Okay, so I'm going to do a few things today. So I'm going to first try to go for homework assignment number 2, which is Wordle. And then if I have time, I will actually go back to the chapter 11, which we really barely start to touch it, which is talk about the concept of classes and objects, which I'm actually going to show you some example, what I call person and the thing. What is a class person? What is a class and thing? Okay, if you can define person and thing, you probably can cover a lot of application. So I'm going to first to talk about Wordle. And by the way, all the code that, let me actually make it a little bit bigger. Is it bigger? Fun. All the code has been uploaded to GitHub, and I share with you in the announcement this afternoon regarding the link. Just go there, check. If for some reason, just to let you know, this is also another my challenge, that we actually have 3 sessions, so I always have to duplicate to other 2 sessions. So if I miss for any reason, please let me know. Okay, so just to let you know that this is, let me actually go for the GitHub. No, this is person and thing. And the repository that I'm talking about is ecs36b Wordle. Okay, this is the directory. I'm going to cover that right now. And in fact, you can use this as a basis for you to create your solution for Wordle for homework assignment number 2. So I assume all of you see, I mean, I sometimes shouldn't make this assumption. How many of you have never played Wordle? Okay, all right. All right. So, well, you have to learn a little bit. Let me actually play a little bit about this game. Okay, just tell you that this is this. If you download the file, and it essentially give you 3 files plus a directory. The directory is called lists. Okay, that's actually. Let's take a look. What's lists? So lists has 2 files or 3 files actually. You can neglect the cache. Okay, it's all about all.txt and solution.txt. So essentially, let's write a command called wc star.txt. So there are 2 files. One is called all.txt, one is called solution.txt. So all.txt means it has collection about 12,946 words. Those are English words. They consider those are legitimate words. Okay. So in this file, that's why they are collecting 12,000 plus words. And then they have a solution words, which has about 2,300. So when the program Wordle C, which means that it's a Wordle program, is written in C. Whenever it generates a challenge for people to guess, by the way, all of them are 5-letter words. They're actually going to pick 1 word from the solution. But you can guess, your guess must be one of the words from the all.txt. Okay, of course you can change that, but this is this particular way. Let's actually take a look at solution. And you can see that those words are all possible words for that. Okay. So essentially, if somebody asks you a Wordle program, you can actually, technically, this is acceptable for homework assignment number 2. It's not the most beautiful thing, but you can do this. Is that I actually just open this file and just grab each of them and just guess all 2,000 whatever words. And then I'm guaranteed I'm going to win, right? If you allow me to guess that many times. So that's, if you take a look at all, this is basically some other words. For example, the first word, AAHED, which I know nothing about, but that is a valid English word, is not in the solution set. Okay, so basically, you actually don't need to worry about this detail. I mean, just explain to you how those file and what's their role. Okay. So let's actually tell you that the first thing I want to do is I'm going to switch back to the directory. And then there is a Makefile. I tell you that I'm going to talk about the Makefile, but before I tell you the detail of the Makefile, I'm going to just generate the, so I have a 2 program here, Wordle C and Wordle ecs36b S2023. So Wordle C was the original Wordle C program. By the way, Wordle C is not developed by me. It's actually developed by somebody else. It's open source. You actually download. So that was the original one. And I will show you this program as well. This program, I kind of provide comments and provide some hints about how and where you can modify, where you can actually, what's the location for you to actually perform your own solution. Okay, so let me actually try to I will make the Wordle original. This is the original program. So you can see that when I type make, I haven't shown you the Makefile. You can take a look at later. It compile using GCC compiler, compile the Wordle C program, and then it generate the executable and make it into this program called Wordle _ORIG. Means that this is the one that's actually developed by somebody else. I'm just compiling and running. So let's try to see how it works. I might need your help because I'm very bad in this game, just to let you know. So this is the interface. It's not a GUI interface is actually very text-based. Okay, so input is new. So I just say, I start a new game, right? And then I start to provide a guess. Okay, so you have 5-letter words. Anybody want to help me? Okay, this is a fresh new game. Anybody want to provide what word I should guess first? For some of you who has been professional in solving Wordle and share on Facebook every day. Yes. Irate. That's the first word my son usually put. I don't know this word, but irate, right? Okay, so when you type irate, by the way, this is a good strategy to use irate. Okay, but I will tell you other strategy. So the program is actually going to print out two string. The first string is actually tell you how well you're doing. So if you see underscore means that irate means I, that is the wrong letter. The letter doesn't exist in the solution. But then if you see O, that means that particular letter, which in this case is R, A, and E, they are in the word, in the solution word, but they're in the wrong position. Remember, 5-letter, right? So that means, for example, R is not in the second position of the solution word, okay? And then the good thing is that if you see a pound sign over here, that means that particular letter, in this case, T, is not only in the solution word, but also in the right position. So now that's pretty good, all right? So now we know it has RATE, and we know T is in that particular position, but RAE is somewhere else. Okay, what should be the next guess? Anybody? Yes. How do you spell that? Oh, Earth. Okay, EARTH. Okay. See, we have some professionals here. Okay, we have some really good professionals. They know how to solve this word, right? Okay. So what is homework number 2? Homework number 2 is actually to deal with Wordle incapable person like Felix Wu. Okay, so I'm really bad in doing that. So when I'm bad at something, I try to write a program to do whatever strategy. So homework assignment number 2 is I want you to actually be able to develop a program or strategy that I don't need to actually get the input from user, such as, what's your name? Oscar. And what's your name? Whoever say Earth. Curtis. Okay, we don't have you guys, but we can actually be able to solve this issue, even with a few more guesses. That's what we want you to do in homework assignment number 2. Okay, so now let me first tell you my modified version, and then maybe you can help a little bit. So I'm going to make, this time you see that I actually type a make, I actually compile this program, Wordle ecs36b s2023.c. You have this code, and I again generate the executable called Wordle ecs36. Okay, so let me actually tell you first what this program is doing. You will see the difference immediately. Okay, I'm going to run this program. And then again, this looks, so far looks the same, right? And I'm going to do new. Okay, when I do new, the program is actually programmed to make the first 3 guesses. Earth, mount, and sticky. Okay, why choose this 3 word? By the way, I'm actually getting this help from my previous class because one of the students say her strategy is always guess this 3 words because it covers 15 letters. So by the way, I haven't actually tell you that this side. This basically say, well, how many letters you haven't tried so far. You haven't tried because it's a strategy. If you already tried this letter and you don't need to try that again. So you see that after I try Earth, Mount, and Sticky, I actually only got about Wow, 11 letter, right? 26 minus 15, I got 11 letter. And now I want the expert to try to help me. So let me just give you some idea what letter is in there, but they are all, you see that whenever I have an O, they're all in the wrong position, right? So this one says E is there, T is there, but they are in the wrong position. U is there, is in the wrong position, and I is there. Wow, this is all the vowel, right? I have E, I have U, I have I, and then I have a T. Anybody want to provide the next guess? By the way, this is not an English class, okay? I just want to, test your. Yes? And anybody want to provide some guess? I mean, don't worry about duplicate the letter. I mean, just any letter will be fine. Any words, 5-letter words. By the way, at this moment, usually I use Google a lot, okay? I always cheat, right? Use Google. Yeah. All right, but this day we should actually use ChatGPT to do that, right? Can ChatGPT help? Yes. You have to help me to spell it. UNTIE, like this. Okay, that's good. That's good. We have 4 letters. It's not N, right? N is not there, but we know the first letter is U, the last letter is E. Yes.
Unite. UNIE.
I think N is not there, but we can try. Okay, UIE is all there. So it must be UTI something E. What's the letter is? It must be UTI, right? And something E. That would be hard for me. For my vocabulary is hard. Okay. Yeah. Huh? Yes. Okay. Thank you. You see, I mean, collectively we work well. Okay. Collectively we work really well. Okay. So I just want to tell you that my program, which is already given to you, already provide the first 3 guesses. But then can you continue this program to actually make sure that you can actually fit to actually produce the rest? Okay. I mean, by the way, I'm not trying to find the best, the optimal algorithm to serve Wordle, but I kind of want you to develop a strategy. For example, your strategy could be just I just go through all the solution word. I open the file, go through all the solution word, and just quickly eliminate if we think that, okay, it's already being eliminated by this array. You can do that. Okay, that's some strategy you can develop. Okay. All right, so I'm going to tell you first the Makefile, then I'm going to go through the program I gave you. Okay. First, I want to tell you a little bit about Makefile. You have been seeing me type make. Some of you might actually learned about Makefile already before this class. And I realized today some of the instructor, even ecs36b, they didn't actually cover Makefile. So I have to give you some basic examples. So number one, I want to tell you for Makefile, a lot of the time you actually don't need to do anything. You just use it. Somebody else wrote a Makefile. Maybe you make minor changes here and there. But it's important for you to start to get exposed to some of the Makefile. Let me actually show you what this Makefile looks like. Okay, this Makefile also include in the directory looks like this. So I'm going to explain to you that the Makefile typically has 2 parts. The first part is about what I call a macro. By the way, if you see a pound sign in Makefile, that means is a comment. Okay, it's nothing. It's just for readability. So the first part, I will call it is a macro definition. Macro, M-A-C-R-O, macros. Okay. So for example, I actually define macro. Capital CC is a macro, is a GCC. You can see that the second line. I actually use another one, which I commented out. I said CC, capital CC is equal to G++ minus STD equal to C++ 14. By the way, this was one of the most commonly asked questions today, or the challenge that you have is that when you try to compile for homework assignment number 0, that you have to use the right version of G++. I mean, when you compile the JSON RPC, the source code, whatever, the server abstract.c and CPP or C, it has error. It's not because the program is wrong, because you're using a different version of compiler. This is one of the reasons I really don't like. I know C++ or C is very powerful, but particularly C++ is really giving programmer a headache because they keep changing. You have a C++ 2K, you have a C++ 17, 14, and then all the way, I mean, the first C++ program I wrote is 1987. And you can consider back then, whatever program I developed is no longer compiled with the new compiler. And right now, for this course and for most of popular program, it's actually C++ 14. Okay, so you can see that I define the macro, and why I have that CC is equal to GCC and capital CC is equal to that is because sometimes I use this Makefile for different development project, and sometimes I want to use GCC, and sometimes I want to use C++ or G++, STD C++ 14. And the thing is that I don't have to change anything that's actually have a capital CC. I just actually change at the macro section. Okay, so that's why under here is all about macro. You see that $, for instance, capital CC. That's corresponding to whatever I define the macro as CC. Okay, it's a software engineering trick to help us to write a readable, portable, and extendable Makefile. Okay, so this part is about what I call macro. Okay, and the second part is I call rule. So what if somebody asks me, ask you what is a Makefile? It's basically have rules with a bunch of macro rules. So now we're going to look at rule. Okay, so a rule, I want to tell you one of the rules. Let me use this as a rule. This is a rule. And a rule has 3 parts. One is we call target, one is we call dependency, and one is what we call action. So let me actually tell you what the rule is. The rule basically is target, colon, and then there's a tab key, and then there is a dependency. And then the second line, again, there's a tab. And then this is what we call actions. Okay, so that is a rule. What is a rule? I should say this is a rule. Okay, so for example, this one, Wordle ecs36b underscore s 2023.0 is the target. This rule is helping me to produce this object file. And this file, this target depends on this file, which is called Wordle ecs36b s 2023.c. So basically say this one depending on this one. If this dependency is true, I will tell you what do I mean by dependency, why it matters. Then I'm going to execute this particular action. This action is basically capital CC, which is I'm actually using GCC. And then with a C flag, which is with some of the flag, I put it in. Usually you typically write it manually, but now that's nice because I have a macro defined there. And essentially you invoke this command. So this line, let me actually tell you that this line is equivalent. You replace the macro into this line. It compiles this file as generate the target, which is the .o file. By the way, I'm using a particular skill we call separate compilation. You see that I'm not directly compile into executable. I compile into .o file first, and then I use another rule, which is the rule next, to actually link this together. So you see that over here, the dependency is actually .o file, and then with this, okay? Okay, this is the rule. Now I think there's two missing pieces I need to tell you, and then I'm done with my Makefile introduction. I mean, you have to use it to learn it, okay, to be honest. So what is a dependency? Dependency is basically say whether the target is older than the dependency. Let me repeat it again. Whether the target is older than the dependency. If the target is older, that means I will trigger the action. If the target is newer, then I'm not going to trigger the action. Why is that? Because think about this case. I actually just modify the file, Wordle ecs36b, whatever. I just modify the file. So the timestamp of the dependency is actually going to be newer than the object file. Therefore, I should recompile. However, if I actually didn't change the .c file, then I have no way to regenerate the .o file because it's wasted. I mean, one file you might not see the difference because consider a large project, which you have about 2 million files, and you only modify one file in the source code. Then when I try to link into a big project, I don't have to compile the rest of the file. I only need to compile. That particular file is just modified because it's older. The target is older. And then I can link everything together. So that's let me show you some example. So let's take a look. Let's take a look at this two file. Wordle ecs36b s2023.c. Oh, by the way, how do I know which one is older? The operating system is actually associate a timestamp, multiple timestamp, by the way, with every single file. And one of the file is that what was the last time you modified this file. When you do ls minus l, ls minus l, that's actually showing that when was the file was last modified. And therefore, you just look at this two line. One is .c, one is .o. There's two files. Can someone tell me which one is older? The .c file is older, right? Because it was produced at 4 o'clock. The other one is produced just now, right? 5 o'clock. So if the target file is actually newer than the dependency, which is the file we have, then it will not trigger the action. So now let me actually tell you how do I try that. If I say make, what's the target? Target is this one, .o. If I say make this target, and it's basically telling me, you see that it says Wordle ecs36b s2023.o is up to date. Why is that? Because the .o is actually newer than that. Okay, that just tell you what's the rule we're talking about. We're talking about this rule. This is the target, and this is the dependency. We're actually comparing their timestamp to decide whether we want to execute this one. Okay, so I'm going to play a trick. I'm going to modify this file. So now is .c, so let me modify, but a virtual way of modify a file is called touch. You have a command called touch, which change the timestamp, just Wordle ecs36b.c. Okay, I'm touching this file. Okay, after I touch this file, I'm actually ls minus l, Wordle ecs36b star. Okay, if you now look at the timestamp, now Wordle ecs36b.c is actually what? Newer. So the dependency now is actually newer than the target. So now if I do this, you take a look at this timestamp. Because I touched, it do that. So now if I run make, if I do trigger the same rule, You see that now it's triggered. It's actually running GCC compiler. So compared to whatever up there, it's already passed. Oh, wait a minute, I didn't pass. Okay, right over here. You see that? This is the previous time I'm actually using this command. It says it's up to date. You don't need to trigger this rule. And over here, it actually realized the timestamp. It will do that. Okay. So that's my my first introduction to many of you about Makefile. So Makefile has two parts, a bunch of macro, a bunch of rules. And how do I actually trigger the rule is actually look at the timestamp between the target, which is on the left-hand side of the column, and the dependency, which is on the right-hand side. So we compare the timestamp. So it's a smart compilation system to help you decide which one need to be recompiled. All right, that's number one. Number two, I do want to tell you is that this rule are actually chain reaction. It's chain reaction. Let me actually tell you what's happening. So if you see that I have a make the first rule, it's called all. That's the default. And that's dependency is actually word executable. And that is actually going to do what? It's going to trigger this rule. And then this rule is actually going to trigger this dependency because the timestamp, it will actually trigger this rule and then to do this. So you are expecting to see this being action first, and then you're going to see this is a second action, and then you're done. That's why when I make a claim, by the way, there's another one called make claim, means I just erase all the object file. So I can have a clean start. If I type make, which is make or make all is the same. You see that? It's actually first compile the second rule in the Makefile, and then it actually generate the third rule in the Makefile. There's two, it automatically helps you to do that. You don't have to type it in. I mean, it's so nice for software engineering project because if we have a team, we just use one single Makefile, and then the team member is going to modify different pieces. And I cannot track who modified what, but I know the timestamp. Therefore, I just type in make, and then it will automatically figure out which one needs to be compiled. Okay. Any question regarding the Makefile I just share with you? Okay. Yes, please.
We're expected to do a Makefile for that.
Yes.
I'm on what's the meaning of what?
Okay, so for homework assignment number 1 is going to be my heel and my break. So I will create one rule, just part of this. So it will be looks like this. It will be my heel.o. And then this will be my heel.c. And then over here will be my heel.c. Okay, and then over here is going to be my heel. All right, go back. And here will be my heel.o. And then over here is going to be my heel. And my heel.o. Something like this. Okay. So just one Makefile. For homework 1, well, homework 1 should have their own Makefile. Homework 2 should have a separate Makefile. I'm just using the same Makefile for explanation.
And are we just putting in my heel then, or are we also turning in my break? Because my break is just your code.
Please turn in both my heel and my break and Makefile, and the Makefile will generate a scoop of both my break and my heel, so it's probably easier for the TA. TA might use his own version of my break, right? Okay. Okay, so it's in Makefile or in a lot of programming. In fact, my experience is that a lot of time you learn from writing some small program or small Makefile, and gradually you see the power about those tools. Okay, that's I hope you too. Yeah.
We're using C or C++.
We're doing C++, but right now because the first homework is in C. Okay, that's an interesting question. Let me actually tell you this. I never tried that, but I think this will work as well. I can actually change this to G++. I can change this to G++. I think it still work. And I don't think I need this one. I don't need C flag anymore. Okay. Let me see. I didn't try it, but I want to give it a try. Yeah, it works. It works. It's just it just gives you a warning saying that I'm treating C input as C++. But the program should work. By the way, G++ compiler is a superset of GCC compiler. So therefore, any program you can compile with GCC, you should be able to compile with G++. Except G++ have so many versions. Like STD, I'm using STD, whatever, C++ 14. That's the hassle we have to be aware of. Okay. All right. So yes.
So you basically, let's say, can I compile the GCC with G++ with GCC?
No, you cannot. Yeah, you cannot compile a C++ program with GCC. GCC is only this.
And I got my question. So do they have to use macros in the Makefile because my previous professor didn't ask me to do that?
Okay. You don't have to, but in my experience, is unavoidable. You have to use macro. Otherwise, for example, if I don't use macro, if I change from G++ to GCC, I have to change so many places. Yeah, if a macro is so easy for me to do that. Yeah. Yes. What? Well, for homework 1 and 2, we don't have header file, right? But for later, yes, later C++, you must have a lot of header file. Yeah, we need to do that. And then the dependency a lot is actually depending on header file, because you modify a .h file and you're going to trigger a lot of rules in Makefile. Okay. Thank you. I'm going to go for now we're going to look at the real thing, which is Wordle. Wordle ecs36b.c. Okay, this is a program we're going to talk about. Okay. So this program, well, I forgot how many lines do I have for this code? Let me just check. This program is about 541 lines. Okay, so we're going to take a quick look about the program, and then so you can is what I call readability about a program. Oh, sorry. Okay, so the first few part is just including file, header file, some of the object, but I want to tell you one thing. It's really over here. You see that I actually make a comment. I said this is for ecs36b S2023 students. I want you to actually take a look at that, because in this program, they have a multiple function. And if you understand the function, then essentially you very quickly understand the whole scope of the program. And then you can actually be able to understand the whole program. So there are a few functions. I should say that there are some function which is actually, it's not very, how do I say that? You probably can skip that. For example, setup is about cache memory. Don't worry about that at all. Pick word, hash word, to lower, check word is word, string position, and then remove. So those are the words, the functions. So let me give you a few examples. I don't have time to give you everything, but I want to actually tell you two functions. One function is called hash word. One function is called to word. What is a hash word? Hash word means that it basically says the 5 letter that you actually, oh, wait a minute. Is that hash word or is that is word? Okay, yeah. Has word is basically say the word you supply as your guess is actually in that whatever the file called. I show you the one file with 12,000 words. Whether that file, that particular word, 5-letter word you provide is actually in that. So that's basically has word. And to lower is that is worry about when you enter the word irate, for example, you might capitalize one of the character. So basically to lower is actually convert to whatever you enter and into the 5-letter, they're all lowercase. Okay, so those are the function. So let me actually go through the program. The first one is actually main program. The main program, you open this 2 file, you see that F open. Now you see that again for homework 2 is actually open all.txt and solution.txt, both with a read mode. Okay. And then of course is start to do first thing is actually the manual. There is a function called manual, and which you probably don't need to worry about manual because it's just the text it actually produce and collect some of the input. Okay, and then then you actually do this is that you're going to do scan loop. If it's a manual, if the new word is actually going to pick a word, means that from the solution is going to pick a word for you based on the game ID. It's going to pick a word. That's the solution word. So basically in the whole thing, just to let you know, word is the 5-letter words that we try to guess. Okay, word is the one we try to guess. But after you've done all this configuration, you enter the most critical part of the function of the whole program is called game loop. Okay, so what you really need to worry about is the game loop itself. It's nothing else. Okay, so let's actually look at the game loop. Yeah, here's a game loop. So, okay, so here's a game loop. It basically has a while loop. It's looking at whether you have guessed too many times, which means that you can actually set it so it doesn't bother you. You can guess as many as you want. And basically the game loop is comparing your guess with the word. That's the solution. So if strcmp is not equal to 0, that means you're going to stay in the loop. But as long as they're the same, if they're the same string compare with this 2, you should probably still remember if you learn C, string compare returns 0 if this 2 string we're comparing is equivalent. So essentially string compare guess and word, if you guess right, that means it's actually the same as word, then you're going to exit the game loop. Okay, so this is essentially inside the loop. You just keep trying. I'm actually not going to the Felix hack first, but you can see that the program is first it print the whatever guess you have, and then scanf is receiving that 5 words, and then do a bunch of processing such as to lower guess. You convert whatever letter you do into the lowercase, and then try to do this guess and the word and trick, and it will in the loop and keep looping until you actually guess it right. I mean, that's the original program. Okay, now I want to tell you, this is exactly the place you can actually make it autonomous. So let me actually tell you this section of code, which you actually got it, is a piece of code. I call it Felix hack. Okay, I basically hack it to it's not a complete solution, but it's actually show you a flavor how you can implement your solution. So you can see that the first one I said, I'm going to try check word earth. I basically asked them to check the word, whether the word earth is actually against the solution. Solution is word, so I say check word. So that's the function you can use. It's original one, but I'm actually using it here. So whenever I said check word, I actually remove alphabet. After I remove the alphabet earth, I actually print out. That's why you actually see me print the whole nice thing about, what's the result. The result is actually printing by check word, but the remaining character is actually printing at this. So you can see that I actually check word earth, and I check word mount, and then I check word sticky. So you can see that I basically just check the 3 words, and then what the program is doing is that if the string comparison of earth and word is any of the 3 words equal to 0, we won. So I basically, I wrote a partial autonomous program such that it automates the process providing the first 3 guesses. And then if your program is supposed to actually develop more, to have a more, okay? Okay, I'm going to stop here. By the way, I want to say today, please don't ask